A honeybee can send GPS-like directions by shaking her body. Inside a dark, crowded hive, thousands of bees move like chaos. But one returning bee carries a secret: the location of food. She cannot speak. She cannot draw a map. So she does something almost unbelievable. She dances. And other bees know how to read it. This is the Waggle dance, one of nature's strangest communication systems. A bee runs forward while vibrating her body, then loops back and repeats. To us, it looks like a tiny insect moving in circles. But to the hive, it is a living code. The angle says where to go, the length says how far, and the energy says if the journey is worth it. The first secret is direction. Outside, a bee uses the sun like a compass. But inside the hive, there is no sky, no horizon, and almost no light. So she turns the outside world into movement on the comb. Straight up can mean flying toward the sun. A tilted run points to food at that same angle away from the sun. Her body becomes the map. The second secret is distance. Bees do not measure distance with numbers. They measure the journey through motion. As they fly, the world streams past their eyes. Trees, grass, flowers, shadows. This visual flow shapes the dance. A longer journey creates a longer waggle run. So flight experience becomes movement inside the hive.
But here is what makes it even stranger. The followers are not watching from a clear seat. The hive is dark, packed, and always moving. Bees press against each other. Antennae touch the dancer. Tiny vibrations move through the wax. Wing beats create subtle air currents. To follow the message.
When Carl von Frisch began decoding this behavior, the idea sounded almost impossible. Could an insect really tell others where food was located? Many scientists doubted it. Maybe bees were just following smell. Maybe they were searching at random. The dance looked impressive, but was it truly information? To answer that, science needed proof. Then, modern technology changed everything. Researchers attached tiny radar transponders to individual bees and tracked where they flew after following a dance. The result was powerful. The recruited bees did not fly randomly. They left the hive in the direction predicted by the dancer. Then, near the expected area, they searched using local clues like smell. The dance was information. And the story gets deeper. The Waggle dance is not perfect from birth. Young bees improve by watching other dances in the colony. Without that experience, their first dances are less accurate in distance and direction. So the dance is instinctive, but learned. The hive is not just a factory. It is a classroom. Now zoom out. One bee does not control the colony. Many bees return with many reports. A rich flower patch creates a stronger dance. A poor source gets less attention. Slowly, the colony shifts its workers toward the best opportunities outside. No leader gives orders. No single bee sees the whole map. But together, the hive becomes a living search engine. Today, scientists use cameras, artificial intelligence, computer vision, and even robotic bees to study this hidden language. Software can detect waggle dances from video and estimate where bees are advertising food. Robotic systems can imitate parts of the dance to test what followers respond to. The goal is not to replace nature. It is to understand how a brain smaller than a sesame seed can share a map. The Waggle dance reminds us that intelligence does not always look like ours. A honeybee cannot speak, but she can turn sunlight, distance, vibration, and memory into a message. A map made of movement, a sentence written on wax. In the darkness of the hive, a tiny dancer shows where life is blooming, and the hive listens.